Today's date is February 19th. It is February 19th daily Leetcode challenge, and we're gonna solve it today. So essentially, questions asking, given an array of strings nums containing n unique binary strings, each of length n, turn a binary string of length n that does not appear in nums. If there are multiple answers, you may return any of them. So all it's basically asking is for each uh, So all these values, all these numbers in here are of some certain length n, and you want to just find a number that is of size n that is not in this list of nums. So I think this is pretty straightforward. Um, I think that the key here is we want to find so over here, for example, so we'll take this as an example. So nums is 0, 1, and 1, 0. So it's basically number one and number two. And so really n, you can just get it right off the first element. You can just say num 0, length of that, which is 2, the size is 2. And so you want to find some number that is of length 2 in its binary representation, which isn't already in this. So this is the key idea that you'll notice once you get used to these kinds of problems is whatever the highest value. So what is the highest like the largest number that is of size 2? That'd be the binary representation of 1 1 where all the bits are filled out or set. So it's 1 1 and that corresponds to 3. So this is the highest one. And the thing is, for any number that is less than this, you can represent it where in a form where there are two like bits. So you can have a 0. You can still represent like a 0 with 2 bits, and that could just be 0 0. So kind of the idea is you want to just iterate through all numbers that start at 0 and go all the way up to the largest possible value that can have 2 bits, which is basically 2 squared, which is 4. So you want to go all the way up to 4, not including 4, because 4 is 1 0 0. And this is 3 bits. So the size n would be 3. So you want to go all the way up to this part because you know that everything up to this part would only have 2 set bits. So it would be 0 0 0 1 1 0 and 1 1. And so you basically just iterate all the way up to whatever that n 2 to the n is, and then you basically convert it into a binary string, and then you just check if it's already in nums. And if it's in nums, then you don't return it. Otherwise, you can return it. So one thing that we will do here is we'll convert nums to a set. That way, we'll have a num set. So set nums. And then all you got to do now is you just got to iterate for I in range 2 to the n. So we can get n just by picking the first element and finding its length. So you can just do num 0 and then just get the length of that. So this would basically be 2 in this example. And you basically just go all the way up to 2 to the n because that would have exactly one more than um that would have exactly one more bit representation than n what we currently have. So it goes up to 4. And then really at this point all we have to do is convert this um I into a binary and then just check if it's in nums. And the good thing is here in this case, since we converted it to a set, then the lookup would just be an O of 1. So it'll be constant lookup, which helps with the time complexity. In this question, it seems like time complexity doesn't matter a lot anyways because constraints are pretty low. But here, so basically we'll get the num. So the num would basically be the binary representation of this I And if you know the this syntax, so for any number, binary of 4, for example. So we'll just take the example here. So if you just print it, then it basically gives us in what like it'll be like 0 B 1 0 0, but the thing is you only want to get everything starting from the second index. So this would be 100. This would be in the string representation. So this is a string. So what you're doing is you convert this I into binary and then get the last place of it. So the everything's from 2 onwards. So that gives you the binary representation of the number. But the thing is, you want to know, the thing you realize is in this case, for example, you have 0 0. So this function would just give you 0, but you want 0 0 because you want the size n. So what you can just do is you can just add the leading zeros by basically doing n minus this. And this would basically give you the number of zeros that you would want to put at the start times 0. This is basic string formatting. And then you can just add whatever this value is. Like that. And then you basically just check if num. So this would basically give you 0 0, like all the full size n. It's basically iterating through all size n binary numbers. So if num in not in nums set, then you can just return this num. And this should work. I think. Yeah. And that passes with the highest complexity. So thanks for watching.